So in this unit, we are going to talk about coordinate geometry. Basically using a coordinate grid to help us solve different types of problems. Okay? And as part of this, we're going to learn how to calculate certain values using coordinate grids and then eventually a formula. We're going to use coordinate grids to graph relationships. We're going to use coordinate grids to find equations, all sorts of stuff that we're going to do. But before we start all of that, this is just a very basic review of how to plot points on a coordinate grid and how to read points on a coordinate grid, which you should all be familiar with. So I'm going to go through this pretty quickly. So there is a fancy name for this thing, but we'll just call it the coordinate grid. Okay? And it's a visual way to show points, to show lines, to show curves, to show shapes, to show relationships. It has all sorts of uses in a variety of different fields. So what is it made up of? It's made up of a whole bunch of little squares that forever. But then what we do in order to plot points on a grid and read points on a grid, we need some reference. So what we do on this big grid is we draw a horizontal line called the x-axis and a vertical line called the y-axis. And where they intersect is called the origin. That is our reference point. The coordinates of that point are always 0, 0. What does that represent? What do the zeros represent? Yes, so the first number represents horizontal movement on the x-axis. Right? It's 0 because we haven't moved anywhere. This is our reference point. This is our starting point. But if we were to move this way, this number would become positive. If we were moved this way, this number would become negative. The second number represents the vertical movement on the y-axis. Right now it's at 0 because we're at our reference point. We haven't moved anywhere. So when we draw these two axes, we create what's called 4 quadrants. And we name them by starting in the upper right and moving counterclockwise around the grid. So this is quadrant 1. Notice we use Roman numerals. This is quadrant 2, this is quadrant 3, this is quadrant 4. Each quadrant sort of has special points in certain quadrants have certain characteristics that we'll talk about in a second. Okay. So, how do we plot points? Instead of having to write all these numbers again, let's just call all of these capital letters and write the capital letters instead of the actual numbers. So if I were to ask you to put the point 2, 3 on the coordinate grid, how would you do it? Sorry, what? Three on the X? Okay, so I start here, and then what do I do? Go to the right 2 on the x-axis, then go up 3. And that's my point. That's point A. Watch your negatives. So in B, again, we start at the reference point, the origin, but this time we're going to move 3 to the left and then 1 up to get B. And you guys should be able to do the remainder of those. So C, 2 to the left, 4 down. D, 5 to the right, 1 down. Remember, zeros in the coordinates mean there's no movement. So E, 3 to the right, and then no vertical movement. So I just stay right there. And F, no horizontal movement, but then down 4 of a vertical movement. And I get that. Pretty straightforward, I think. Okay. And of course, the other thing that you can do is go backwards. You're given the point, you have to write the coordinate. So in example 2, here you're given a bunch of coordinates, or you're given a bunch of points, you have to write the coordinates. And when I say coordinates, I mean the two numbers in parentheses separated by a comma. What would A be? 4, 2. Because from the origin, I have to move 4 to the right and 2 up to get to A. So we're all familiar with that. How about B? -2, +5. C? -3, -3. D? 4. I can't hear. -3. E? 0, -1. And F? 5, 0. Again, you should be familiar with all this. Okay. And then just one last point to make. Every time you put a point in this quadrant, quadrant 1, both numbers will be positive. Every time you put a point in quadrant 2, the first number x will be negative, but the second number y will be positive. When you put a point in quadrant 3, both coordinates will be negative. And when you put a point in quadrant 4, the x coordinate will be positive, the y coordinate will be negative. Any point that's on the y or x axis will have a 0 in its coordinate. Okay? So that's just a very quick review. Plotting points, reading points. Because we need that information to start looking at some different coordinate geometry concepts. First of all, distance between 2 points. Okay? Well, I mean, one common use of this, finding distance between 2 points, is maps. Okay, like whenever you see a map, it's always broken up into grids. And then you identify by usually a letter or a number. Okay, that's how you can identify. And then if you want to tell the distance between 2 cities or something like that, you have to use that information. And then find the distance or the length between the 2 cities. But the question is, how do you do that using a graph? Sometimes it's obvious, sometimes it's not so much. Like, look at segment AB. Starts at A, ends at B. What's the distance from A to B, or the length of that segment? 5. Pretty easy by counting, right? Why did I double this up? This should say CD. I don't know why that says AB twice. And again, so a vertical segment, pretty easy to find the distance, just count. Okay. Horizontal would be the same thing. What would be the distance from C to D, or the length of CD? 7. So those are pretty straightforward. But then, what happens if it's a diagonal segment? Like, you can't really count it out because, I mean, from here to here, that's not 1 unit. That's, I don't know, 1 point something. It's a little over 1. I have no idea. So I need to come up with an alternate way. I need to use my previous knowledge of math to figure out a way. How could I find the distance from E to F, or the length of E to F? Ella? What kind of triangle? Yeah, make a right triangle out of it. Because you'll know the length of the legs, which means you can find the length of the segment, which is going to be the hypotenuse in the right triangle you created. So by counting, we know that's 3, that's 4. And therefore, by Pythagoras, we can find EF. So we can't, so we can find it using Pythagoras. So basically, a squared plus b squared equals c squared. So 3 squared plus 4 squared equals EF squared. That's the distance I'm trying to find, or the length I'm trying to find. 3 squared is 9, plus 4 squared, 16, is equal to 25. And therefore, to find EF, I just take the square root of 25. And it turns out it's going to be exactly 5 in this case. You're not always going to get a whole number for the distance. You could get a decimal number, okay? Or you could leave it as a square root that we talked about in Unit 1. So that's great. I can do all of them now by graphing. But if I asked you, if I just gave you the points, like if I just said as an example, don't worry, I'm still going to use this page. Like if I said, find the distance between those 2 points. Well, right now you would have to go through the whole process of drawing a coordinate grid, plotting the points, connecting them, making a right triangle, and using Pythagoras. That's not very efficient. So what we want to develop is a formula so that we can, if we're just given the points, we don't have to do all that work. We can just use the formula to help us. And here's how we develop the formula. If you think, going back to this one, what are the coordinates of this point? 1, 1. What are the coordinates of this point? 4, 5. So, if you think about it, the legs of the triangle actually are the differences between the x and y's. So how did I get 3? Well, the difference between 1 and 4 is 3. So if I did this minus this, I get this leg, the horizontal one, if I subtracted the horizontal coordinates. Same thing with the vertical. So this is the same as 4 minus 1. This is the same as 5 minus 1. So you always need 2 points. So if we're given 2 points, and let's just call them, let's call the first one x1 comma y1, and call the second one x2 comma y2. Let's think about what we're doing. So to find the length of AB, or to find the distance from A to B, and that's the fancy math notation we use, lowercase d, A to B, okay? First of all, I need to know the lengths of the sides, then I need to do Pythagoras. Well, how do I find the lengths of the sides? I find the difference between the x's and the y's. So I take the second x minus the first x, second y minus the first y. That gives me those lengths. What do I do with them now? Pythagoras. Square them, right? And add them together. So I square them and add them together. And that equals the third side squared, doesn't it? But I'm not done yet, though. I don't want the side squared. I want the side. So what's the last thing I have to do? Square root. There is the formula. Okay? You will always be given this formula. Okay? I'm not going to ask you to memorize it because I'm more concerned with how you use it than how well you memorize it. But that's how we develop the formula. So if this allows us, we don't have to do all that graphing and sketching and Pythagoras stuff. Kind of doing it all in one big step here. So let's practice using this formula. It doesn't matter which one you call x1, y1, and which one you call x2, y2. It doesn't matter. But just, this is the one that's first. So I'm going to call this one x1, y1. And I'm going to call this one x2, y2. So to find the distance between those 2 points, well, I have to take the second x minus the first x, according to the formula. 0 minus 3. Then I have to take the second y minus the first y. Negative 5 minus 1. Square them and add them together. That's the Pythagoras part. And then square root. That's how I build the numbers into the formula. And now you just got to use them or do the math. Always use parentheses. Always use parentheses. Because you got to be careful. 0 subtract 3. And what is negative 3 in parentheses? Actually, you know what? I'll write it. Negative 3, and I still have to square it. What's negative 5 subtract 1? Negative 6. And what's negative 3 squared? 9, positive 9. Whenever you square a negative, you always get a positive. Plus negative 6 all squared. 36, so I add those two together, and I'm now at square root 45. But you need to look at the question. It doesn't say express your answer as a decimal. You don't pull out your calculator, punch in square root 45, and round it. You leave it in square root form, but it has to be simplified. How do we simplify? That's when we did the highest perfect square thing in Unit 1. That's when we broke this down, where this number was the highest perfect square that goes into 45. What is the highest perfect square that goes into 45? 9. Which means the other number must be 5. And why did I do that? Because the square root of 9 is exactly 3. And I can't do anything with the square root of 5, so I just leave it as 3 times the square root of 5, or 3 root 5. That's expressing it as a mixed radical. Okay? So you've got to read the question carefully, because we want to express the exact answer. This answer is actually more exact than the square root of 45 on your calculator. Because as soon as you punch it into your calculator, it's becoming approximate. Okay, last example. Here we have a triangle that's put on a coordinate grid. We're told the coordinates of the corners of the triangle, or the vertices. Okay? P, Q, R. We're asked to find the perimeter. Well, how do you find the perimeter of a triangle? Add the sides. So that means I have to know the length of each side, don't I? So that means I have to know the length. I have to figure out the length of PQ. I have to figure out the length of PQR. And I have to figure out the length of PR. Which means I need to use the distance formula 3 times. This time, notice it says round your answer. So this time it's okay to use a calculator. But I've got to use the distance formula 3 times. So let's talk about the distance from P to Q. First of all, it's going to be a long square root. And then we're going to have like that. And now we got to just make sure we put the correct numbers in. So look at the points P and Q. Let's call these two x1, y1, these two x2, y2. So what's x2? 2. What's x1? -3. So I have to do 2 minus -3. Be careful. So it actually changes to a positive because it's 2 subtract -3. And then the y's are the second y minus the first y, 6 subtract 5. That's easy. So I'm going to save myself a little bit of time. What is 2 subtract -3? Squared? 25 plus 1 equals square root of 26. Can't take that exactly. On my calculator to the nearest tenth, that's 1 decimal place. Should work out to 5.1. That's one of them. I want you to find the other 2 now. Practice finding the other 2. So you need to use the distance formula again to find the distance from QR, or the length of QR. And then also the length of PR, or the distance from P to R. So let's do the distance from P to R, or sorry, Q to R. That was the next one. So my big long square root, my 2 sets of parentheses with a plus in between and each getting squared. So I should get, if I do QR and if I call R the second x's and y's and Q the first ones, so I should get -4 subtract 2. -4 subtract 2. And 14 subtract 6. 14 subtract 6. Well, -4 subtract 2 is 6, -6, and -6 all squared is 36. Plus 14 minus 6 is 8. 8 squared is 64. Add those 2 together under the square root, and I get square root of 100, which is exactly 10. So that one worked out to an exact number. And finally, P to R. I'll just do it over here. A big long square root, two sets of parentheses, with a plus in between, squareds. So P to R is going to give me -4 subtract -3, which means it's going to actually work out to plus. And then PR is going to be 14 minus 5 for the Y's. So -4 plus 3 is -1, all squared is +1. Plus 14 minus 5 is 9, squared is 81. That gives me the square root of 82, which means I got to use my calculator. And I should get 9.1. So the final step is the perimeter. You just add the 5 lengths you found, 5.1 plus 10 plus 9.1. And that should give us 24.2 as the perimeter. Final answer. And there's no units, so yeah. What's that? Oh, yeah. You know what? Technically, yeah, you are finding the approximate answer, so that's good. Yeah. Okay. That's distance. That's one value we can find using coordinate geometry. There are a couple of more values. One, midpoint, and the other one, perhaps you know from science, slope. Or maybe you haven't taken it yet. I don't know. But it will be helpful. If you haven't taken it yet, it will be helpful in science.